Hi guys, let's welcome back to our lesson. Today I'm going to talk about chapter 2. I divided chapter 2 into 4 videos. In today's videos, I'm going to touch about 9.1, which is simplifying algebraic expression, and 9.2, constructing algebraic expression only. Okay, firstly, let's revise the law of indices that we have learned in chapter 1. Imagine if we have x power a, then meaning to say we are going to time x a times. And if we have x power b, we are going to time x b times. All right? So the first law is like that. When we have x power a times x power b, we are going to plus the index a plus b. Then we have answer x a power a plus b. Right? As for example, if we have x power 2 times x power 3, we have x power 5. And if we have x 8 power 2 times 8 power 3, we have 8 power 5. As to the extension of this, let's say we have a number in front of x a and x b, just like we have when we have m and n. So basically, the law is still applied when we do this. But when we have a number in front, we need to multiply the number also, become m times n. You put it in front, and this one is following this law, because when this one times this one is basically like this. So the answer is like that. Okay. So for example, when we have 2x squared times 3x cubed, our answer will be 6, because 2 times 3, 6, x cubed, x squared will get x5. Right? So the next law is about divide. If we have x power a divided by x power b, then we are going to minus the index a minus b. Okay, this x is called as base. A is called index. Right? For example, if we have x power 2 divided by x power 3, we have x power negative 1, because 2 minus 3 you get negative 1. When we have a number like 7 power 2 divided by 7 power 3, we can write the answer as 7 power negative 1. Or you can write in fraction. Remember, minus 1 means 1 over 7 power 1. Okay? So, follow from this same law, extension to it. When we have number like m and n in front, basically m will need to divide by n, just like that. You can write in fraction like that. Or if you can simplify, you simplify it. Otherwise, just leave the answer in fraction, and x power a divided by x power b will get x power n a minus b. For example, if we have 2x squared divided by 3x cubed, so we'll divide 2 with 3, right in fraction. The x squared 2, this one 2, need to minus 3, you get minus 1. This is how we write the answer. If we have 3x squared divided by 2x cubed, we have to write 3 first on top. 3 is going to divide it by 2. Right in this way. Then x 2 minus 3, you get minus 1. Okay. So we may have another case like when we are going to plus xa plus xb. For this case, it is not the same like multiply and divide. We cannot apply the law like plus the power. Basically, this will be the simplest way to represent an answer. So basically, when you see this kind of answer, this question, this is the final answer. We cannot simplify any further. For example, if we have x squared plus x cubed, the answer still remain as x squared plus x cubed. We cannot combine these two, okay? But when we have a number like that, 2 squared plus 2 cubed, we can individually find out what is this, which is equivalent to 4. 2 cubed is equivalent to 8. Then we can plus these numbers to get 12. Only when they are in numbers, we can simplify it further. Otherwise, this will be our final answer. Follow this law. When we have plus and minus, basically, this will be the final answer. Okay? For example, this one, x squared minus x cubed, the answer still remain the same. But when we have the number like that, we can individually find out what is this value and find out what is this value, then get the final answer, which is -4 in this case, 4 minus 8. All right. So basically, this is how we simplify an algebraic, right? From this become 1, from these two terms become 1 terms. All right. Next one, we are going to learn how to construct algebraic expression. For example, in an algebraic expression, the letter represent unknown numbers, just like x, a, y, b, that kind of things, right? Unknown numbers. We often need to construct algebraic expression to help us to solve some problems. For example, if a represents the price of an adult ticket, b represents a price of a child ticket for a concert, let's say, and a in this case is bigger than b, meaning to say the adult ticket is more expensive than the child ticket, right? So if I want to total up the price of one adult ticket and one child ticket, when we write in expressions, it will be A plus B. This is the price for the adult. This is the price for the child, right? But when we have 2 tickets of adults and 3 children tickets, we are going to write 2A plus 3B. That will be the total price we are going to pay if we are buying 2 adult tickets, 3 children tickets. And if you want to find the difference between the adult ticket and the child ticket, the expression is going to be like A minus B. We are going to minus the A price with B, then to find the difference. Okay. For example 2, let's say William thinks of a number n. I don't know what is a number. I represent it with the letter n. The question asks you to write down an expression in terms of n. That means our answer must include n for number Williams get when, let's say A, when he doubles the number, then add 5. When he doubles the number, that means he is going to multiply 2 with the n, then plus 5. This is the answer. B, he is going to divide the number by 3, then subtract 6. So basically, n need to divide by 3 first, then minus 6. This is the way we write the answer. C, we add 3 to the number, then multiply the result by 4. Basically, we need to plus 3 to n first, and in brackets, we need to multiply 4, just like this. We need to plus this first before we times 4, right? But normally, we put the 4 in front, just like this, instead of we put 4 at the back of the brackets, right? D, multiplies the number by itself, and then halves the result. So that means the n need to times the n when we have n squared. After that, we divided with 2 because we need to halve it. E, subtract the number from 2, then divides by 3. Meaning to say we need to use 2 to minus the n first, then divides by 3. So this is the answer. 2 minus the n first, then the total answer divided by 3. Okay, so basically this is another way of, from a sentence like that, we need to convert it into an expressions, right? Next one, we see some picture that's like this. Let's say this is a rectangle with the length 2x and the width y. We are going to write an expression for, let's say A, the perimeter. How are we going to write the perimeter of this rectangle? So rectangle, basically, we have to plus the 4 sides to get the perimeter. So 2 of 2x plus 2 of the y. 2 of the 2x plus 2 of the y. So when we combine this, it's going to be 4x plus 2y. Remember, these two are different terms. We cannot combine these two, right? And B, let's say the question asks for an area. The area of this one basically is the length here times the width here. So 2x is going to times y. So in algebra, when we times, we combine the letters, just like this, 2xy. Instead we write like that, okay? Followed by another example. Let's say we have a triangle like this with the length here, A, B, and C. And we are going to find the perimeter again. So in this case, we are going to plus all these 3. So A plus B plus C will be your answer. In order to find area, basically is the height times the width, then divided by 2. All right? A times B divided by 2. So in algebra, we write in this way. Okay? Next one, let's say we have a square with the length 2 minus P. The same thing, we are going to find perimeter. So because the length of the square are the same, so basically we have 4 of them. We multiply it, we can write in this way, or you can expand it. 4 times 2 get 8. 4 times this negative P will get negative 4P. For area, basically it will be this times this. All right, so that's why I bracket it. This one multiply this one. You can write like that, power 2, because we are multiplying the same thing, or you can expand it. Okay, so for this explanation or expanding, I'm going to talk in video 4. Stay tuned. Okay, so basically these are the few examples of how to construct an algebraic expression. All right, so that is the end of this video. You have 2 exercises to go, and this is at page 85 to 87. Okay, see you later. Bye.